You know that feeling, right? Staring at a really tough exam question and you just freeze up. You know the stuff, but you have no idea how to actually get the marks. Well, what if I told you there's a kind of secret language that examiners use, and if you learn it, it could change everything? Today, we're going to crack that code.
Okay, so picture this. We're looking at a higher tier non-calculator maths paper. The stakes are definitely high. That little symbol means it's just you and your brain, no safety net. And in these exams, believe me, the final answer is only part of the story. The real points, the ones that make all the difference, are scored on the journey you take to get there.
So, what are they really looking for? I mean, that's the million-dollar question, isn't it? Are they just waiting for some flash of genius, a perfect, flawless answer? Or is it something a lot more systematic, like a set of rules you can actually learn and, use to your advantage? All right, so here's the game plan. We'll kick things off with the examiner's checklist, then we'll jump into our first challenge, perpendicular lines. After that, we'll decode the marks to see what's really going on. Then we've got a second challenge with some tricky surds. We'll uncover the secret code behind it all and wrap up with a winning strategy you can take with you. Okay, let's start with the examiner's checklist. And here's the thing. You might be surprised to find out that the most important rules, they're not some big secret. They're literally printed right there on the front of your exam paper. So take a look at this. You've got your standard instructions, answer all questions, read carefully, but one line just jumps off the page. It's our golden rule for today. You must show all you're working. And let me tell you, that is not friendly advice. It's a command. It is the absolute key to unlocking those marks. So let's see exactly how that works. All right, time to put that golden rule to the test. Let's tackle our first challenge. This is a pretty standard question. It's got a few steps, which makes it perfect for seeing where you can either scoop up points or lose them. Okay, here it is. Question 12. We've got a straight line L with the equation 2y equals 3x minus 7. Our job is to find the equation of a different line that's perpendicular to L and passes through the point 6 minus 5. And for this, there are 3 marks up for grabs. So how would we solve this? Well, here's a pretty logical approach. First things first, we need to rearrange that equation into the y equals mx plus c format we all know and love. That gives us the gradient of L, which is 3 over 2. Okay, step 2, we need the perpendicular gradient. So we flip the fraction and change the sign, the good old negative reciprocal, which gets us negative 2 over 3. Great. Step 3, we take the point they gave us, 6, negative 5, and substitute it into our new equation. Step 4 is just solving for c, the y-intercept. A little bit of algebra, and bingo, c equals negative 1. So for our final step, we just write out the full equation, y equals negative 2/3 x minus 1. Looks about right, doesn't it? But the real question is, where did we actually earn those 3 marks? And this is the moment of truth. Let's pull back the curtain and take a peek at the official mark scheme. This isn't just a guide. This is literally how an examiner is trained to think. Okay, check this out. Here is our very first clue. The mark scheme gives you 1 M mark, that's a method mark, just for showing you know how to find the perpendicular gradient. See that? Just by getting to negative 2/3, you've proven you know the method. And just like that, boom, you've already banked 1/3 of the points for this question. And it gets better. Look at this. The second mark is another method mark. Now, this is the really cool part. You get this mark just for correctly substituting the point into your equation, even if your gradient from the first step was wrong. That's huge. The examiner is rewarding you for knowing the right procedure. It's a test of your understanding, not just your ability to get every single calculation right. And that brings us to the final point, an A mark, which stands for accuracy. Now, this one's for getting the final answer spot on. But here's the catch. You can only get this A mark if you've already picked up the M marks for showing the correct method. So the lesson here is crystal clear. Showing your steps, showing your journey, that's what unlocks every single mark. Okay, so that was a fairly standard question. But does this whole method marks thing still apply when you get something that looks, well, a lot scarier? Let's find out. Let's take a look at question 22 from the same paper. Yeah. When you see a question loaded with surds, these pesky square roots, it is totally natural to feel a little bit of panic. But just take a breath and remember the principle we've been talking about. The examiner wants to see your process. So forget the scary numbers for a second. What's the very first logical step you would take here? And this is amazing. Just for setting up the problem correctly, literally just writing down that the common ratio is the third term divided by the second term, you earn a P mark. That stands for a process mark. You haven't done a single difficult calculation yet, but you have already scored a point just for knowing how to start. How good is that?
So what's the next step? Well, to simplify a fraction with a surd on the bottom, we have to rationalize the denominator. And would you believe it? Just for showing that you know you need to multiply the top and bottom by the conjugate, you get another process mark. We are 2 marks in and we still haven't had to do the really complicated multiplication. This right here, this is the whole point. The system is literally designed to give you credit for understanding the concepts. It's there to separate a tiny calculation error from a complete misunderstanding of the topic. And that right there is why showing your work is so incredibly valuable. So these M marks, these P marks, they're not random. They are part of a system. You can think of it as a code, a special language that tells you exactly how you're being graded. So let's go ahead and learn that language right now. And here it is, this little table of abbreviations. It comes straight from the official marking guidance. Honestly, you should think of this as your Rosetta Stone for exams. Understanding what these letters mean isn't just helpful, it's like having the examiner's own personal cheat sheet. Okay, so it basically boils down to this. You've got M marks for showing a correct method. You've got P marks for a correct process. Think of those for the more complex, multi-step problems. Then you have A for accuracy. But remember, that usually comes after a correct M or P mark. Sometimes you'll see C marks for clear communication. And finally, B marks. I like to think of these as brilliant marks. They're for a correct answer that's so simple it doesn't need any method shown. So there you have it. We've decoded the marks. We've learned the secret language. The big question now is, how do we wrap all this up into a winning strategy you can actually use on exam day? I want you to try and think about it like this. The final answer is just the destination. You're working, that's the journey. And the examiner wants to see that journey. They want to see every correct turn you made, every logical step you took. Your working is basically your travel diary for that problem. So here's the winning strategy, the big takeaway. The next time you're faced with a question that just looks impossible, a question with tons of steps, don't panic. And please, don't leave it blank. Just start with the very first logical step you can think of. Write it down, then write down the next one. Just focus on collecting those method and process marks. They're your safety net, and you'll be surprised how often they'll guide you all the way to that final accurate answer.
You know, this way of thinking, it doesn't just work for math exams. It applies to pretty much any complex problem you can think of. Coding, writing an essay, even planning a big project. The secret is always the same. Break it down, show your process. So it leaves me with one final question for you. What complex problem will you break down next?